Okay, previous to this in this booklet, we looked at echoes. Echoes are where sound waves are reflected off solid surfaces. And what we looked at was if we time how long it takes for that sound to get from wherever it was produced to the solid object and back again. And if we know the speed of sound, we can then work out how far away that object must be. And dolphins and bats use echolocation, and some ships and submarines use it as well. However, we can do exactly the same thing, but using either radio or more likely these days microwaves. The advantages of radio waves and microwaves compared to sound waves are they travel much quicker. So we can use this to determine distances that are much larger than we could with echoes. You know, if we wanted to know where a plane was using an echo, we would have to have a massive speaker that plays out this deafening sound. Um, that travels all the kilometers to this aircraft. Small amount of it gets reflected back. We'd have to have a very sensitive microphone to pick that up. But by the time that sound wave gets back, that plane's going to have moved a considerable distance. Therefore, um, that's why we use radar. That's why we use radio waves or microwaves to detect objects. Now, we're going to look at this through an example. So it says the radar at a control tower. So let's do a little drawing where we have our little airport. And here's our little control tower that sends out a radio wave to an aircraft. Okay, so there's our aircraft. It gets reflected off that metal surface and travels back to our little dish. Okay, now that's one of the way these systems work. So we have our radar system at the airport, but airplanes can also have radar systems on them that can detect objects around them too. We're told that the time that this takes is 25 microseconds. So we say that the speed of light is much larger. So if you look here, it says the speed of light is 300 million meters per second. Okay, so all types of light, not just visible light, as you're going to see later in this book, and when you look at the electromagnetic spectrum, which includes gamma rays, which you've come across before, infrared, thermal radiation, but also radio and microwaves and UV and X-rays, they all travel at this speed here. It's a very fast speed, much quicker than the 330 meters per second of sound. But that means then the time taken for these reflections is also going to be much smaller. Okay. Um, so if we look more closely at the time, okay, so we have a time of 25 microseconds. Now that little symbol there is for microseconds. We've come across things like kilo, mega, milli, centi, all those things tell us something about the quantity that's being measured in. Micro is just like that. So if we had something that was in milliseconds, that would mean thousandths of seconds. What this micro means is millions of seconds. So that just means it's 25 divided by, so to convert from microseconds into seconds, we have to divide by 1 million, which means that that is, if we write it out in full, is 0.00025 seconds. Okay. The speed is 300 million meters per second. We're dealing with some very big numbers and some very small numbers here. You can just do it like this. You can enter that in your calculator. You can enter this in your calculator. You can type this little sum into your calculator. But what is actually much easier is if you're used to using standard form of maths, you may not have come across this yet. If you haven't come across in year 11, you will in year 12 in your maths lessons. We have another way of writing big and small numbers. So we can just say that this is exactly the same number as 3, but multiplied by 10 8 times. And we just write as 3 by 10 to the 8. What we can do with this microsecond is micro is exactly the same as 10 to the minus 6. So rather than having to do this whole sum, I can just type that into my calculator as 25 by 10 to the minus 6 seconds. This works. If you're happier doing that, type that in, but you're more likely to kind of put in an extra 0 or leave out a 0, I think, if you deal with those numbers. So these questions are all speed equals distance divided by time. It's just the numbers are big or small. So I can do 3 by 10 to the 8 for the speed, or else I could just type this in, equals the distance, which you're trying to find out, 25 by 10 to the minus 6, multiply across by the time, and that gives us our distance. If you type that into your calculator, you're going to get 75 by 10 to the 2, which is just that. However, this is still a reflection question. If you remember from our echoes, we always had to remember to divide or multiply by 2. And if you notice, this time is the time taken for the sound to get out, or sorry, the radio or microwave to get out and back again. Therefore, that distance is the distance out to the airplane and back again. So in fact, what we need to do at the end is divide by 2. And that gives us that the distance is 3,750 meters. However, if we look at this unit, it's in kilometers. So we have to divide by 1,000 at the end to get it into kilometers, and that will give us 3.75 kilometers. Okay. So we're just doing exactly the same things we do for the echo questions, only the speed's much larger and the times will be much, much shorter. That's the only difference here, okay? Try the questions below. Once again, I'll post a little video at the end that goes through the answers, okay?